We've started on this idea of the chain rule, and we had these 5 examples. The one in purple we've already completed. We still haven't written down a rule, and I have to admit, it's probably pretty confusing right now. Let's go ahead, try and make this look a little easier. Well, now this might look a little more complicated, but here's the steps that we were following. We want to determine the different types of functions that we have, the inside and the outside, take their derivatives individually, multiply them together, and then back substitute. So it kind of looks like these compositions of functions. That's what we're dealing with here. So that first problem, when I say sine of 3x plus 9, we know that sine is the f function and the inside one is the g function. That's how we identify it. We have the inside and the outside. And it's much easier when it's written with parentheses to determine the inside and outside. But this is the notation for compositions, quite often just that small open circle. However, coming back to our regularly scheduled mess, let's take a look at these functions one by one. So for that first one, pick out the inside and outside. If you didn't notice this, we happen to use this letter U quite a bit. It just signifies a block, another function there. It just has to be the letter we use. No particular reason, but it's nice. So we break it out, big function sine, little functions 3x plus 9. Derive them. Please note that since this is written in terms of u and x, the derivative is u and x. This is y and u, and the derivative is y and u. Then I'm going to multiply these two functions together, du over dx times dy over du. Notice the du's will divide out. You're left with dy over dx. 3 times cosine of u. Back substitute. What is u equal to in this problem? It's written down. Use it. There you have it. Let's take a look at the next one. Break up the inner and the outer. Notice I didn't write down the g of x. I just said y. It just seems easier for me to do that. Also, 16 divided by all that stuff is just 16u to the negative first. There are ways to make this a simpler process. Their derivatives are quite nice. Double check those. I'm going to multiply those two different derivatives together. This is a little messy. This says dy over dx. I know I rewrote it. I should probably just go ahead and say what the derivative is. As a matter of fact, I'm going to back substitute there also. This should give me a nice, easy answer. Well, that's messier looking, but it is the correct answer. I have 9x squared plus 2 times negative 16 over u squared. I did write it as g prime. If you want to write dg over dx, that's fine too. It's just the nomenclature. Now, for the last two, take a second, pause the video, find the inner and outer functions. If you can do that, you're well on your way to success. Just as a quick aside to help us out with this, what is the difference between these 3 trig functions here? Well, 2 of them are exactly the same. Both of these mean I'm taking the entire cosine function and squaring it. This one here means I'm just squaring the angle. So that key will really help if you understand what those exponents represent with trig functions. That'll help you in putting together the inside and outside functions. The inside function is actually tangent. The outside function, the bigger part is we're taking something to the fourth. So here we go. We've got the last 2 problems here ready to be solved. And when we do this, remember your trig functions, remember your power rule, but most importantly, don't be afraid to use the quotient rule when you need to. It's a little bit long. It might be slow, but it's actually necessary to get the correct functions here. And now it's time for a little shortcut. Do you notice anything about all of these functions? It turns out for each of these, if you take the derivative of the outside function and then just multiply by the derivative of the inside function, you wind up getting the exact same answers as all of these. It can be simplified to say the derivative rule for the chain is the derivative of the outside times the derivative of the inside.